We're gonna talk about it right now. All right, so check it out. These, and don't worry, we don't know how to do them right now just yet. Look at the percentage of students getting these questions correct. Look at number 26. Only 25% of the total population in 2008 got this question correct. Look at number 28. It's even more brutal. Only 14% of the total population got this question correct. The fives are even struggling. 38% of the fives got this question correct. 13% of the fours got it correct. And then forget the 3, 2s, and 1s. They're just barely hanging on. I mean that with love. No, don't worry. You're going to get it right. All right. Why do I suspect? There's many reasons for these percentages, guys. Maybe one of them could be that maybe teachers just failed to look at these problems and went right over it because it's such a small percentage of inverse problems that maybe they just said forget it and went on to the next. Or maybe they did, but students just don't understand the concepts at hand. You okay, Miss Kyle? You okay? Yeah, for sure. All right. So here we go. I'm not going to do question 28 or 26 right now because we don't know it yet. We're going to do, so go to the second page. Yeah, spooky edition because we're almost at Halloween. All right. Review what it means to be inverse. Algebra stuff. We're going to start with simple stuff. So when you guys were in Algebra 1, you guys had functions like, and I'm just making this up, guys. F of x equals 3x plus 9. And your teacher probably told you, find the inverse of this function. So what did you do when you found the inverse? You switched what over what? Yeah, x and y's, right? Is that how you guys found it first? So you went x equals 3y plus 9. And then you solved for y. So you put the 9 over there. X minus 9 equals 3y. And you divide everything by what? 3, divide by 3, divide by 3. And then you get something that looks like this. 1/3 x minus 3 equals y. And this is my inverse function. So this is what I'm going to write inverse, like this. Oh, you're good. You're good. Do you guys remember that? So this symbol here means inverse. Well, derivative is an instantaneous rate of change. Inverse, you're just flipping the x and the y. It reflects across the line x equals y or y equals x. So we haven't done anything. We haven't done anything yet with derivatives. Okay. Are we still okay? All right. Let's do one more so we can observe what's happening. So I'm going to write just gx, and I'm just making this up. Let's see. What do I like? 2x plus 8. All right. I'm finding the inverse. I'm going to switch one and what? Nothing crazy. I'm moving the 8 to the other side. I divide everything by, and then I call that inverse. So I'm going to write g of x, or g to the negative 1 of x, equals 1/2 x minus 4. Are we still okay? Okay. Here's what I want you guys to recognize something. I want you guys to recognize that my original slope, these are all linear lines. Notice that my f prime of x here on this one is just 3. You guys notice that? I want you to notice f prime of negative 1 of my inverse function is 1/3. What do you notice about the 3 and the 1/3? They're reciprocal. That's exactly the word I wanted. They're just reciprocals of each other. Yay or nay? Now, of course, we're just doing linear lines. So right now, these things are easy. What's my slope of g here? 2. What's the slope of the inverse of g? 1/2. They're just what? Reciprocal. I guess you could say inverses, but the better word is reciprocal. Do we see that, guys? What's up?
What's the notation? Oh, okay, so it's f negative 1 prime.
Yeah.
X. Okay, because I was like, what's the notation?
Yeah, f negative 1 prime. Put the f negative 1 in parentheses.
So the inverse of f of x is the reciprocal of f prime of x. Can we write that like for notes?
No, well, I haven't. I just found I haven't done anything yet. Just linear lines. I don't want to. You want to, but no, because we don't. Okay, because I'm right now. I'm going to give you another one, and let's see if we get it right. Okay. Are we still okay, guys? Okay. No, don't worry. Those are just linear lines. Linear lines are not a big deal. All right, here we go. Calculus involves. Let's do a visual first. I'm going to draw a grid. All inverses reflect across what line? Yeah, say it loud and proud. Say what first? Y equals y. Where? Okay, guys. What do I reflect across what line? Not x, not the x-axis. X equals y or y equals x. Come on, guys. Okay, where did I confuse you? Let's stop. Where did I confuse you? All I said is what line do inverses reflect across? Oh. If we have gaps, it's going to be hard. Y equals x is the line where you reflect your inverses. Are we still okay? Nothing crazy? If I draw an exponential function, it doesn't have to be perfect, guys. I'm not looking for perfection. And I reflect it across the line y equals x, I'm going to get a logarithmic function. Exponentials and logs are inverses of each other. So if I tell you y equals 2 to the power x, what's the inverse of that? You would say log base 2 of x. If I tell you y equals e to the x, you would tell me y equals n of x is the inverse. We're good, right? Yeah. Okay, don't worry. We'll write stuff down of what we should know. All right, so here is a log, and I'm going to put a point. So let me go, what should we know? What should we know cold? So let me go ahead and write it like this. I'm going to call this graph f of x. I'm going to call this graph g of x, and I'm going to say that g of x is the inverse of f. Because it reflects over the y equals x. Are we still okay, guys? It's not. I didn't draw it perfect. If I have a point here, a comma b, then this point here is b comma a. Okay, so you guys remember? Yeah, you guys remember. So look, what we know. So remember, I told you that g is the inverse of f. So I'm going to write f of x here. I'm going to write g of x right there. Are we still okay? We know, let's see, we know that if f of a equals b, then we know that g of b equals a. Are we still okay? Bless you. Because they're inverses. So the point AB switches to BA. Are we okay? Okay. I'm kind of worried here, but let's try it out. Let's see. I'm just gonna make this up. Ready? If I tell you f prime of a, I'm just going down the alphabet, equals c, a, b, c. They're all row numbers. Then what do I know? So let me write this down right here. I know that f prime of a equals c. Then what do I know about the inverse function? Okay, tell me. Let's see. What was your idea? F prime of a. No, f prime of a is f. This is still f. Yeah. What do I know about g? G prime of what? C. Okay. No.
1 over a.
No. No. Now you guys are just guessing. Stop. Let's think about it. All right. Yeah. Stop. You guys are going too fast. So I'm telling you that okay. Let's go back over here to the front, to the top here. I found my slope of that was 3, and I found that this slope was 1/3. Okay, someone said it right, but I don't know who. Well, tell us why it's 1 over c. Yeah. It's the reciprocal. But here's what I want you guys to notice. Notice that says g prime of c. It does not say g prime of a. That c was a y value. Oh, that's why I got you guys confused. Who told me C and I wrote C and the guys never fixed it? It's not C. G prime of what? Did I say C? My bad. Okay. Yeah, that's my fault. That's my fault. Let the record show that I messed up here.
So if it was C, would it have been
No, there is no C in there. There's never a C in there. The only no.
Is it B?
Which one is it? It's
B. I don't know.
guys, look. Look.
Chuck said A.
It's not A.
B.
Tell me why it's B.
Because. What did you say? B. Because it's the inverse. Basically.
This B was the Y value on the original function, but it's now the X value on the inverse. Don't worry, we're gonna do a lot of examples, so hopefully we didn't mess you up. Let's time out, guys. Slow down. Too hype. Don't follow the pattern. Don't be a robot. Let's make sure we understand what's going on. Guys, this point right here, AB, when you do the inverse of that function on my logarithmic function, look, it now turns to be A. So if I know f prime of A is equal to C, I know, what do I know? I know G prime of B, not G prime of A. It's because this B was a Y value in the original. And now it's an X. Does that make sense?
Can we do this with numbers?
Yes, we're going to do this with a whole bunch of numbers.
I was like, these letters are confusing.
Yeah, I messed up. Dina, do we understand that or no? Bam, ask me.
4 plus 4.
You got it for sure. Price? We got it down. Okay. Let me say it again, guys. Let me say it again, just in case. Remember this coordinate, A comma B? When you take the inverse on G, that coordinate, AB, turns to BA. Are we okay? Kind of. Okay. Don't worry. We're going to do a lot of examples. Okay. Let's see if we're ready.
I'm picking up the crumbs of what you're
Yeah. Let's see if we're ready. So
microwaving.
look what this says here. This says exactly the same thing that we just said. So maybe I should add it right here. Look, remember that we said that the G was the inverse of A, the inverse of F? So maybe you want me to write it like this. F negative 1 derivative. And then put of B equals, and what was the word that they used when we used, this was 3, this was 1/3, this was 2, this was 1/2. So it's just a reciprocal 1 over F prime of A. Just a reciprocal at A, which was your X value.
I like that.
Cool or not cool?
I like that.
Don't be a robot. Do not be a robot. It's very easy to become a robot. If you're a robot, you're only going to memorize it for a little bit, and then come the real deal, you're going to forget it. Remember why it's reciprocal, guys, because they're inverses. If the function is easy enough, you can find the inverse equation. If you have y equals x squared, okay, that one, you can find the inverse of that. It's y equals square root of x. And yeah, you don't need to know all these fancy formulas. You can just find the inverse function and then just find the derivative and find the slope at any given point. But that's not going to be the case. You're going to have some functions that you're not going to be able to find the inverse. Does that make sense? So look, let's go down here. Let's check this question out. This is from UH. Maybe they're being nice to you guys. Maybe they're being nice. How do you do these? Draw a table. You know, as a matter of fact, I'm gonna make one of my own in a little bit. Make a table, not draw. Make a table. So we'll do this one together. So suppose that f has an inverse function. So they're telling me this. So let's see. So here it is. Here's my table, and they're just calling it f and the inverse of f. So I'm gonna write f of x. I'm going to write f negative 1 of x. That means inverse. And what do I have right now? I have f of negative 7 equals 2. So over here, I'm going to write f negative 1 of 2 equals 7. Yeah, this is what we know. What we know. Because they're inverses. It just reflects across the line y equals x. So if I have something in quadrant 3, it's going to go to quadrant it's going to go to quadrant 1. Yeah. Do you know what I mean? It is negative 7. Sorry, miss. I thought you were telling me to switch the value. Yeah, look. If you have something here, it's just going to go here.
How do we know it's there?
Well, you don't. The x value. Yeah, you do. The x value is negative in quadrant 2, and the y value is positive. Okay. So in quadrant 4, when you reverse it, the x value is going to be positive, and your y value is going to be negative. Okay, ask me.
I was looking at your hair. Okay. Sorry.
Okay.
I was thinking about how you used to be.
Oh, we're good. Guys, focus, guys. Have I lost anyone? Yeah. Yeah, remember the x turns to the y turns to the x. Why does it do that? Because it reflects across the line. Y equals X. You can say X equals Y, but Y equals X. Are we still okay? All right, let's see. I'm going to focus. All right, here we go. We know this. We know that f prime of -7 equals 4/5. Recognize that this is derivative at 7. For the inverse, I don't know the derivative at 7. I know the derivative at 2. Good job. At 2, because that was a y value on the original. That's what they gave us. What is this? What is my new slope at, or not? It's not new. What is my inverse slope at 2? 5/4. Do you see how we did it, guys? All right. This one wants us to know what is the derivative of the inverse at 2, and what am I going to write? 5/4. Let's make up a new problem. I don't remember. I don't remember what we did for summer. I don't remember putting it. The inverses. You just found inverse equations, I think. Yeah, we did, but not like this, though. Okay, new problem. So I'm going to tell you that G is the inverse of F. And I'm just going to go down the number systems here. Let's see. G of 2 equals 3. G of 4 equals 5. So then I'm going to write G prime of 2 equals, what's a good fraction? 1/2. G prime of 4.
And this is just for practice.
Yeah, this is just for practice. Equals 1/3. And let's see, this time I want to go opposite. G is the inverse of F. I want to know what F prime of 5 is. Take some time, see if you guys can figure it out.
So simple that it's not.
Right, make a table.
Wait, but you never gave us the value. Oh, there you go. I see it.
What do we know? This time we don't know F, we know G. Well, we know more of G. Remember that F and G are inverses of each other, yes or no? Because I wrote G of X equals F negative 1 of X, which means that they are inverses. So here we go. What do we know? We know that G of 2 is 3. So if we know that G of 2 is 3, what do we know about F? F of 3 is 2. Are we still okay? All right. Don't worry, guys. Okay, let's see. I know that G of 5 is 4. So if I know that G of 5 is 4, what do I know about F? Perfect. Okay. Now, what do I want to know? I want to know. Yeah. Oh, yeah. G of 4 is 5. Sorry, guys. Look at those mistakes. G of 4 is 5, so F of 5 is 4. Okay, are we still okay? All right, here we go. G prime of 2 is 1/2. So if G prime of 2 is 1/2, what do you think F prime of 3 has to be equal to? How did I do that?
That's what I said.
Yeah, because they're inverses of each other, so I have to take the, what is it called? The reciprocal. I know that G prime of 4 is 1/3. So if G prime of 4 is 1/3, what do I know about F prime of 4? F prime of 5, sorry. 3. Do you guys see how we did it? So what is F prime of 5? 3. How do you feel?
No, go back.
Okay, well, we're about to do another one right now. All right, look. G prime of 4 was 1/3 because that was given, right? Are G and F inverses of each other? Yeah, they are, right? I tell you right here that G and F are inverses of each other. I say it right here with that statement. So if G prime of 4, remember, that's a Y value on the X. So that means I need F prime of 5. So all I got to do is take the reciprocal of the 1/3.
Is that because G of 4 plus 5? So then F.
G and F are inverses, right? So if G of 4 equals 5, then I know that F of 5 equals 4. Ask me, miss. I want to see where.
I think it's just confusing because it's like.
Yeah, you can see why this is tough, but we're going to get it.
But it's like, I don't know, like to me it just seems so easy that it's hard. Yeah.
Okay, look.
It's easy, but it's just.
Let's do it again. Let's do it again until we get it.
Really easy.
All right.
Get one question, one value wrong the whole thing.
Okay, look, check it out. Look at this next question here. Suppose that f of x equals 2x plus 6 squared of x. This one's going to be easier because they don't give you so much information. It's differentiable and has an inverse function for x greater than 0, f of 4 equals 20. Find the derivative of your inverse at 20. You are not, okay, one thing you're not going to do, you're not going to find the inverse function. You could if you wanted to, but you have a linear component and you have a square root component. You're not going to be able to find it. Are we okay? Notice that 20 on the inverse was a 20 on the original. Look, if that 20 on your inverse, that's an x value, was a y value on your original. That's what I wanted to say. We notice that, guys. So I'm going to find the derivative of the original at what value? At 4. And whatever value I get at 4, I'm going to take the reciprocal. Do you see the game plan?
Yes.
All right. So do we need to make a table for that?
Yes.
Make a table. So here we go. F of 4 equals 20. And here's f of x. And here's f negative 1 of x. So if f of 4 equals 20, f negative 1 of 20 equals 4. So hopefully you can see this right here, easily. So now look, if I know f prime of 4, which I don't know yet, but I will. If I know f prime of 4, whatever that number is, then that means I will know f prime of 20. Can you explain why?
Because it's the inverse, right?
It's the inverse. So that 20 was
Was a y value.
on the original, and now it's an x value? Yeah. So
It makes sense.
it makes sense. Now it makes sense.
Yeah.
Rodriguez, does it make sense? You can be honest.
No, yes. But then after that, like when we find f prime of 4 and then do that, we have to find the reciprocal.
You just take the reciprocal, whatever that is. Kyle, ask me. Do we good? Okay, here we go, guys. You don't need a calculator for this. This is probably one of those that they'll ask you in a non-calculator section. What's the root of a 2x? 2. Plus, make a side note, that 6 to the square root of x is the same thing as 6x to the 1/2. So derivative of 6x to the 1/2, that's going to be, what's half of 6? 3x to the...
Negative 1/2.
All right, so here we go. 2 plus 3 over square root of x. You're done with calculus. You're just doing simple arithmetic. F prime of 4 equals 2 plus 3 over square root of 4. 2 plus, what's the square root of 4?
2.
All right, so now I have that. So turn that 2 into 4 over 2, I guess. 4 plus 3, so 7 over 2.
So it's
2 over 7.
Okay, it makes sense.
Whatever that is, you take the reciprocal.
I think this one was probably because we got a lot more information.
Yeah, a lot more information. And that's exactly what we're going to do right now. What's up?
We can automatically take out C, right? Because it says for any values that are greater than 0.
No, because what if I would have done a negative value? I guess if you think about it, yeah, you're going to be always adding. So, but I would not take out any on this one, like this type of problem. I would not take anything out just immediately. All right. Do you guys think we can, how do you feel?
That one I could look out.
Okay. So let's see. Let's go to page 1. It's okay, guys, relax. If we get this one wrong, I need you to tell yourself that it's okay. This is our first day doing this. And remember that these kids that took this AP exam had the whole year. This technically was the hardest question. No, I'm not even kidding. I'll show you guys the test, or if you guys still have it. This technically was the hardest question in that year. This question right here. You guys ready? Do you guys have access to a laptop or something so we can take data on this? All right, so let me go ahead and start, and then in a little bit, whenever you're done, go to that website, guys. Did everyone answer over there? Did everyone answer here? Okay. All right, everyone answered. Here we go. So you guys think it's between A and C. Well, let's see. Let's see what the real answer is.
Matter of fact, everybody's wrong.
No. Okay. What do I do first? Make a what?
Table.
Make a table. Did you make a table?
Yeah, I tried.
All right. F of x.
It's just like I can't formulate my ideas on the table.
No, well, that's the whole point of a table, to put your ideas down on. All right, hey, relax. We're good. Look, slow down. You're going too fast. Okay, look. G is the inverse of F. So make a note of that. If you want, you can put it right here. And then you just start, okay, I'm just going to write whatever I have here. So F of 3 equals 15. So what does that mean about G?
G of 15 is equal to 8.
Okay. Is everyone okay with that? All right. Then I have F of 6 equals 3. So I'm going to write F of 6 equals 3. So if I know that F of 6 equals 3, what do I know about G?
G of 3 is equal to 6.
Is everyone okay about that? All right. Look at, now here we go. Here we go. Here's the fun part. F prime of 3 equals negative 8. What does that mean about G?
Is that G prime of 15 is equal to 1 over 8.
Perfect. G prime, can you tell us why?
Oh, because the y value now became an x value, and now it's the inverse of the original derivative.
There you go. That's it. But that, okay, do they want G prime of 15?
No, they want the other one.
All right, let's go to the other. Look, even if you don't have, like, just putting this here, I think you'll get there anyways. F prime of 6 equals negative 2. What does that mean?
That means that G prime of 3 is equal to 1 over 2.
Make a table. If you make a table, the chances are high that you will get it correct. And if you did not get it correct, guys, it is okay. We still did a lot better than 14%. We still did a lot better than 14%.
I got it right.
Yeah, you lost me.
Okay, where did I lose you?
You lost me. You lost me at the two last step. No, I need chocolate.
Okay. No, we're good. You see this x value here? Since f prime of 3 is negative 8, comma, we know the slope of our inverse function.
So you have to take the inverse and then the reciprocal?
Yes. Well, we're taking the inverse, and then whatever you had on the original, you take the reciprocal of that slope. Since f of 3 is negative 8, we know the slope of our inverse function at x equals 3. Because f prime of 3, no, at x equals 15. That's for the 3 one. At x equals 15. That's just part of it. That's not the whole thing. You need a y, right? Okay, remember this. Let me see. That's 3. So I have something that looks like this, miss. 315. So, and then 15. So I have a point here, and let's see, it's a negative. So I'm just going to do it with this. Hopefully with this visual, because it's, all right, where are you? All right, real quick. De Leon, did any of this make sense to you?
Yes.
You can say no.
Yes, it did.
Okay. If you know the slope of your original right here at AB of your f, then you know the slope of your inverse at that point. But notice that this value changes. It was originally an A, and now it's a B because that B was a Y value on the original. So on this one, and of course, this is just part of it. I guess let me continue writing. And then since f prime of 6 equals negative 2, comma, we know the slope of our inverse function, bless you, at x equals, that was a 6. What's the y value? 3. So if I know my slope at 6 for the original, then I know my slope at 3 for the inverse. If I know my slope at 3 for the original, then I know my slope at 15 for the inverse. Did that make sense? Okay, tell me. Tell me what I said. Tell me what made sense.
It just confuses me whenever we put numbers to it. Like I understand the letters, but whenever we put numbers to it,
But remember, when you're inverse of something, AB turns to BA. So if I have 3, 4, that turns to 4, 3, right, for the inverse function. So if I know my derivative of the original at 3, and I'm calling my y value of 4, then I know my derivative of the inverse at 4. Right?
Okay, I think I get it.
Don't worry, we're going to do a whole bunch. How are we feeling, guys? Okay, can we do some inverse trig? No, let's do. Oh, I know. Okay, I remember. I remember, Miss Cruz. I'm gonna take your advice into consideration. So, all right, let's go. Don't worry, guys. They're together. Many people think the inverse trig is easier because there's not much thinking involved. You're just gonna do it. Okay, ready? So, okay, Miss Cruz. Miss Cruz likes to know where we're going first.
Oh, okay. Call me out like that, I guess.
Oh, I'm sorry, Miss. Should I not call you out? Some student in here. YouTube, don't worry. Look, now you got me thinking of Arc 10. I did that. Don't worry.
Is that a U?
That's a U. Put the U in parentheses. We're gonna get there. We're gonna do it.
Is the U squared or the whole thing squared?
It's the U that's being squared. All right. First, go ahead. S. I'm taking the derivative of U, so it's just du dx. It's just chain rule. One. It's whenever we've done chain rule, we've never put a negative in front of the.
I'm just asking because it's 1 minus.
No, it's one. Look, is the U in parentheses? Yeah. So it's just a derivative of your U, du dx. It's not. Yeah. This is like a 1U. Taking the derivative of U. Still okay? Yeah. That's not. It's not minus. It's not plus a negative U squared. It's minus and then whatever that's my formula. Don't worry, we're going to derive it. All right, so let's derive this formula. The whole point of deriving this formula is for you guys to know that these just don't come from math. They're just not made up.
We're not robots.
We're not robots. We're just going to do it once. And if you guys want to do some more, swing by after school and we can do them all if you want. I mean, I don't know. Maybe we have time. We'll do it in class. You guys ready? So what I'm trying to get to is this. So we already know what my derivative is. So let me go ahead and write an arrow. And I'm trying to get this to look like 1 over square root of 1 minus x squared times 1. So there it is. I want it to get to look like that. I want it to look like that. Well, not yet. It doesn't look like that yet, but it will. It will.
What happened to the du dx?
That's chain rule.
So then do we have to put it again?
What's the derivative of x?
Oh.
Okay. No, ask. Are we okay, guys? Okay, here we go. I don't know this. We don't know this. At least not yet. That's what we're trying to figure out. So let's do some algebra. And that relax. That's the same expression as saying sine y equals x. I haven't done anything. Have I done anything crazy? No. All right. What do we want? dy dx. So I'm going to take the derivative. We just finished implicit with respect to x. What's the derivative of sine y? What do I put next to it? Equals, what's the derivative of x? 1. Can we get to there? Okay. There you go. Child, that's not 1 over square root of 1 minus x squared. What do we got to do? What formula do you know? What identity do you know? Valentine's formula. What's my Valentine's formula?
Cosine squared plus sine squared equals 1.
You got to keep the argument the same. Well, you see how I have 1 over cosine y? Yeah. That does not look like 1 over square root of 1 minus x squared. But I want that. And I can get that by simply writing this in terms of cosine y. Move that sine squared to the right. Cosine squared y equals 1 minus sine squared y. Some of you maybe can see it already. I need to take a what? Square root. Whatever you do to one side, you do to the other. All right, so let's substitute 1 over square root of 1 minus sine squared y. We are almost there. No, go ahead. Go ahead. No, well, ask me. Oh, you figured out what you put. What'd you do?
Oh, I was confused as to why you have the 1 over because whenever you take the square root, that's what's equal to cosine.
Look at what sine y is equal to, guys. So doing substitution,
So it's now.
did we get what we wanted?
Yeah.
Yes. Are you going to be doing this over and over again every time you see an inverse sign? I mean, I guess you could if you wanted to. But if you just,
I prefer not.
yeah, just memorize it. It's not the three that come out. Maybe I shouldn't say this because too bad. I already said it. The ones that are coming out the most on your exam is arc sine, arc cosine, and arc tan. The big three: sine, cosine, tangent, and the inverse of those: arc sine, arc cosine, arc tan. Guess what arc cosine is? Take a guess. Just take a guess. Remember, okay, ciao. I don't even know where to begin. The derivative of sine is cosine. The derivative of cosine is negative sine.
Negative.
It's going to look exactly the same, but what?
Negative.
Look at you guys using context clues. d dx of arc cosine of u is equal to negative 1 over square root of 1 minus u squared du dx. Everything's the same except for that negative. It's just chain rule. You just put it to the side.
Oh.
All right, so here we go. All I'm doing is chain rule, guys. I just want to know if we can use the formula. You guys ready? All right, so let me write the formula right here for you. d dx of arc sine of u, notice the u, u's differential with respect to x, 1 over square root of 1 minus u squared. Notice I put a parentheses on the u, du dx. Are we okay, guys? All right, here we go. The derivative of arc sine of x squared is 1 over, you guys lead me. What do I write on the bottom? Not everyone at the same time.
1 over square root of 1 minus x squared squared.
Am I done?
No.
Times 2x. Let's make it pretty. Here's my derivative. 2x in the numerator. Square root of 1 minus x to the fourth in the denominator. You can leave it alone like that. How do we feel, guys? Okay, tell me. Yeah, I just plugged it. Oh, it's just taking the derivative. That's what the derivative is. It's not any, there's no, if this is the derivative of arc sine. It's like a definition in English. Is it the algebra or? Yeah. Yeah, no, that's it. It's the same thing as a definition in English, guys. This is just a definition. Here's how it was derived. We derived it. This is a definition by derivation. So here it is, just using my formula. Cool or not cool? Yeah, no, that's it. Let's do one more, and then we'll see if we can tackle the question in the front. And don't worry, guys, we're almost done.
Wait, are these
Yeah, these are the formulas. So here are the formulas. It says the most common rules, the most common ones that you got to know are these three. Those are the three that come out the most. If you go to the Facebook groups or you go to the forums, there's always fights on arcsecant. Sometimes they put absolute value. Sometimes they restrict the domain. We do know, well, okay, maybe I'm getting ahead of myself. So just relax. If you see those, they'll probably be in the calculator section. You won't see it in the non-calculator. You will see these three, though. We still okay? And then I put here, let's do chain rule, guys. So that just means we already did chain rule on this one. Let's do chain rule on this one right here. d dx of arc cosine of u equals negative on the front, 1 over square root of 1 minus u squared du dx. And then d dx of arc tan of u. And all I'm doing is just looking at this. If you Google it, you might see it. X squared plus 1, it's the same thing, guys. 1 over 1 plus parenthesis u, close it squared, du dx. Arc cotangent is the same derivative as arc tan. The only difference is that it has a what in the front? A negative. It starts with a C, so it has a negative. Any trig that starts with a C is going to be negative. Are we okay, guys? Yeah, no, look. Okay, here we go. A particle moves along the x-axis. We're almost done, guys. We're almost done. With a position equation given as x of t equals arc tan squared of t. And we just did related rates. What is the velocity, or we did rates, right, and related rates. What is the velocity of the particle at t equals 16? So how do I get velocity from position? A derivative. So all we got to do, so I have x, so let me rewrite the derivative. X of t equals arc tan or inverse tan, however you prefer to say it, and put square root of t is your argument. Make a little note. All right, here we go. The derivative, so I'm going to write dx dt, show the reader or whoever is looking at your work that you're taking a derivative. Dx dt is equal to v of t, which equals, what's the derivative of arc tan? I'll put the definition right here, guys. d dx of arc tan of u is equal to 1 over 1 plus u squared du dx. All right, so I'm going to write 1 over 1 plus square root of t, close it, squared, times, I'm not done yet. What's my derivative of t to the half? You're done with calculus. Everything else is just arithmetic, guys. How do you get better? You're going to have to do some problems. That's all. All right, let's solve it, guys. V at 16 without a calculator. So let's see. 1 over, let's put the 2 square root of t here like that, parenthesis, well, I guess 16. Put a 16 in there. 16, and then 1 plus square root of t squared. So that's going to be 1 plus 16. Close it. Is everyone okay? Okay, what happened? I just did this. You see this part here that I'm circling? That's just t, and I put this together. I guess let me change my colors. That's together like that. You see this 2? It's in the bottom. You see this t to the negative half?
Oh, you did it all in one step. Okay.
Yeah. So.
I thought you did it. I thought that was just the first fraction. So you just showed.
Okay. All right. I mean, all right. We're good. Tough crowd. 1 over 2 square root of 16 times 1 over 1 plus 16. Okay, let's start from the beginning. Let's not even put a 16. V of t. Here, more steps. So I have 1 over 1 plus t. Does everyone know how I got that? Times 1 over 2 square root of t. Does everyone know how I got that? This t to the negative half, you bring it down, right? Are we still okay? Okay. When I combine them, 1 over 2 square root of t, open parenthesis, 1 plus t, close it. Remember, that square root of t was being squared, so it turns to t. Don't worry, right now we'll check it with a calculator just in case. But pretty confident that it's correct. Are we still okay? V of 16. 1 over 2 square root of 16 times, what's 16 plus 1? 17. So I see, if there's no issues, 2 times 4 is 8. 8 times 17. 20, 40, 60, 81, 20, 40, 60, 160 minus 3. 160 minus 24. 50, 40, 136. I do it in steps, guys. I did 20 times 8, and then 17 and 20 are 3 away. 8 times 3, 24, and then I did 160 minus 24. I could be wrong. I make mistakes all the time. Should we check it? Okay, let's check it. I'm checking it, guys. I'm checking it. Here we go. We could have gone to Desmos also.
You're right.
That's right. Okay, I take Ms. Rodriguez's word into account, so we're good. Last one, or 2 more, and don't worry, we're done. We're almost done, because the last one's not even going to tickle you guys. Or, I don't know, give your brain a tickle. Not like, okay, stop. Hey, PG-13, guys.
What?
Okay, stop. Yeah, hey, relax. We'll be fine. All right. Huh? Hey, you think I'm still gonna do an air punch? What? Find an equation. All right, we're good, guys. We're almost done. Find an equation for the line tangent to the graph. Y equals arc cotangent x at x equals -1. A little bit of pre-cal, but it's not even extreme. It's baby pre-cal. I need two things for a tangent line. What do I need? Okay, let's get the point first. Child, I don't know if I can do this. Yes, you can. Stop. Don't say that. You guys all had pre-cal because you guys had me. Okay, here we go. What this means is cotangent of some radian equals -1. I'm looking for where is cotangent -1. The very first one I hit. Remember that cotangent is just x divided by y. There is one in the fourth quadrant, but you want between 0 and pi. You want the one that you hit first. What radian is that? So my y value on this is 3 pi over 4. Can you guys do that? Yes. Now I need to find a what? A slope. How do I find a slope? Derivative. What's the derivative of arc cotangent? It's the same as arctan, but with a what in the front? So I'll put a negative and then look at the derivative for arc cotangent, or I guess let's look. What is it? Look at this. 1 plus x squared, since it was x, see? Du dx, the derivative of x is just 1. Are we still okay? Okay. Oh, I haven't plugged in yet. This is just my derivative. Oh, I know. I should have put a -1 in here. Yeah, so here it is. Y prime of -1. -1 over 1 plus -1 squared equals -1 over...
Oh, wait, you took the inverse?
That is, it was inverse. This is inverse. So there's no really thought into it. You just take the derivative.
What if it was like 2x?
It was not x squared. It was x.
Why for y prime of -1 is not y prime of 3 pi over 4?
If I plug in a 3 power 4, it's a constant. If this is a y value. My x value is -1.
But because the square is a part of the formula, x is not squared by.
Ask me, Houston.
No, I don't know.
This is pre-cal.
You took y, right?
Yeah, this is just arc cotangent of x. My x coordinate is -1. So what I want to know what my y value is. So you say, okay, arc cotangent of -1 is 3 power 4. You know what I mean? Ask me, Kyle. Okay, do you guys want to see how this one looks? I kind of do. All right, let's go to Desmos. Don't worry, guys, we're almost done. Give me like 3 minutes, and then we'll call it a day. Look, Desmos. I'm going to type arc cotangent x. It's going to graph the principal branch. It goes on forever, up and down, but y equals cotangent to the power -1 of x. There it is, arc equals cotangent x. And I'm looking at what point? -1, comma, 3 pi over 4. Do you see that point right there? I better have a tangent line at that point. So let's see. Y minus 3 pi over 4 equals, what was my slope? -1/2 x plus what? Look at that. Is this my tangent line? Are you not entertained?
You are very entertaining.
Okay. Oh. Like, you don't like it at all?
No, I like calculus. I like how.
All right, don't worry. We're almost done. We still haven't done that tangent problem, remember? The arctan? But don't worry, guys. Look, we're almost done. Look at this.
And will you say that this is easier than the other one?
It is. You'll see right now. We're going to have a higher percentage, I'm sure. Evaluate the limit and express your answer in simplest radical form. When you see this, what is this limit saying? It's just saying to take a what? Derivative. You've known this already for many times. I just brought it up just in case, because you're going to see that right now in delta. Limit as h approaches 0, f of a, I guess I got to change that x to an a. F of a plus h minus f of a all over h. So this is finding the derivative of arc sine, and it's being evaluated at a, which is 1/3 in this case. Cool or not cool? Cool. So here it is, guys. All I'm doing is this: f of x equals arc sine of x. I'm taking the derivative. Do it 3 times, and you'll have it memorized. The derivative of arc sine is 1 over minus times 1. You don't need that because now I understand your question, because you said why isn't it 2x? It's x. That's your quote unquote u. It's not x squared. It's x. Okay. Are we still okay, guys? Okay. Here we go. F prime evaluated at 1/3. 1 over square root of 1 minus 1/3 close it squared. You're done with calculus. You're just doing arithmetic. No calculators. 1 over square root of 1 minus 1/9. Are we still okay? Yeah, that 1 turned into 9 over 9. Yeah, you're perfect. If you don't need to do that if you can see it. 1 minus 1/9 is going to be 8/9. 1 over square root of 8/9. So this is your law of exponents. 1 over square root of 8 over square root of 9. You can do keep, change, flip. Bring that 9 up or the square root of 9 up. So you're going to have 3 over square root of 8. Don't leave it like that, guys. It does say simplest radical form. 4 times 2 gives you 8. What's the square root of 4? So 3 over 2 square root of 2. And they probably want you to rationalize it. Don't worry, we're almost done. 3 square root of 2 over 4. Yeah. Sorry, I saw that after the fact. It's supposed to be square root of 2 over square root of 2. And I didn't put that square root in there. Square root of 2 times square root of 2 is 2, and 2 times 2 is 4. We're still okay, guys? All right. Can we do one last question, and then we'll call it a day, and then you can practice, take a 2-3 minute break. Relax. Go to the front page. This is supposedly the second toughest question, or I think it was the third. We'll look at the test right now. Only 25% of test takers got it correct. Let's see if you guys can. So this is the last question. I'll put the poll up. Not work it out for you guys. All right, Ms. Vega, swing by. Yeah, right now.
Okay, I'm being for real. I'm probably gonna ask her to give me the equation again if I forget it. But to start off, I rewrote it because I don't like looking at the arctan written that way. And then I found the derivative. So, let me put. How do you erase?
Reverse it like a pencil.
Oh, nice. So then I rewrote it with the equation. So it's what, 1 plus x squared, right? And then.
Hold on. Oh, okay. You're just giving that. You're just writing the derivative equation.
Oh, it's d over dx.
Well, because you wrote this as y. See how you wrote this as y equals arctan of 4x?
Mm-hmm.
If you use 4x, then what do you mean in here for x?
Oh.
You know what I mean? Like you should have probably done it in the side.
I was gonna plug it in like this next, and then write it in. Or I could just write it in right now.
That's fine. I guess with that. No. Well, yeah.
I'll just write it in right now.
Yeah, there we go.
Alright.
Nope. Delete that 4x there.
Oh.
Because if you put a 4x there, then it's 4 times 4x. Times.
And then just found the derivative, so it's gonna be 4, right?
Yeah, it's kind of correct.
And then yeah, I just plugged in the x, so it'll be if I could. Oh, okay, I see what you're saying. I see what you're saying. So then if you plug it in, 4 times 1/4 just 1. Keep everything the same. And then just simplify. So 1 over 2 times 4 is just going to equal 4 over 2, which is just equal to 2.
We got it right.
Okay, actually, but you know what I'm trying to say?
Yeah, no.
The argument was, so you can't put 4x in there because then it would turn to 16x. All right, guys. Let's see how we did as a class. And I bet you it was higher. And before I let you guys go, here's will be your official little break. Make sure everyone answers, guys, because I don't see everyone answering.
Josh's computer wasn't working.
Okay, make sure you tell me that on an email when when you see the participation. You know what I mean? Yeah, you submitted it. It's not there. Okay, there it is.